Welcome to the WANdisco Fusion lesson on Hive, Live Hive, and other plugins. The topics are as follows. What is Hive? The main features of Hive. Hive data structures. How do you use Hive? Live Hive proxy introduction. Live Hive proxy architecture. The Hive Server 2 template. Installation. Double layers of coordination. And configuring replication. What is Hive? Hive is the data warehouse service built on top of the Hadoop infrastructure. It provides a SQL-like language called HiveQL for querying Hive tables. Hive was adopted and put in as a service to Hadoop to allow data warehousing-like functions in Hadoop. When Hadoop was originally developed, HDFS data was queried via tools like Pig or with MapReduce programming. The general population of users wanted to be able to leverage SQL skills that they were accustomed to using on data warehouses like Netezza, Teradata, Oracle Warehouse. And with the advent of Hive in Hadoop, large volumes of data were able to be queried for analytics using a SQL-like language. That's a benefit of Hive, and hence that's why it's called the data warehouse for Hadoop environments. It supports schema on read versus schema on write. Traditional database technologies support schema on write, which means you have to have the schema, the rigid schema in place before you make the write. It's just the opposite with Hive, where you can put the data into the Hadoop clusters any way you want, and then upon read, you can define the schema for the data that lies in HDFS. It transparently converts queries to MapReduce, Apache Tez, or Spark jobs. It's used for creating analytical reports for knowledge workers, again, to leverage the SQL skills that these knowledge workers already have. And the data is stored in the warehouse, is uploaded from operational systems such as marketing, sales, databases, or other sources that's brought into the Hadoop environment. There's support for both online transaction processing and OLAP types of data, but the queries are OLAP type queries. What is Hive, the architecture? You could see the main components of Hive as they sit in a Hadoop cluster. One of the key services is the Hive Metastore service that integrates with the Hive Metastore database. This is typically a SQL database that runs in the cluster. MySQL, PostgreSQL are some popular databases used for the Metastore SQL database that houses the metadata, the table names, the column names that go along with Hive, and also interacts with the HDFS data where the actual data is stored. And the Metastore service keeps track of and creates the table structures. For example, in a directory, the default directory where Hive data is stored, every database is a directory, and underneath the tables, you can load HDFS data, as many files as you want, and apply the schema on top of that. Yarn is for the scheduling, and the interfaces to Hive are through the Hive Server 2. This provides a JDBC interface, a beeline command line interface using the Thrift technology. The main features of Hive: it allows you to index data to provide query process acceleration. Different file types such as plain text, RC file, HBase, and others are capable of being used in a Hive warehouse. It's very common to see comma-separated files loaded into HDFS and queried by Hive. The metadata storage is in a relational database that significantly reduces the time to perform schematic checks during query execution, and these relational databases in Hadoop are typically Postgres or MySQL. There's extendable serialization and deserialization used to read and write table rows. Operating on compressed data stored into the Hadoop ecosystem using algorithms including deflate, BWT, and snappy, etc. So these are the type of operations you can perform on compressed data that is stored in the Hadoop ecosystem. The built-in user-defined functions can be used to manipulate date strings to support other data mining requirements. Hive supports extending the user-defined data set or sets. Supports only OLAP types queries of data at this time. The Hive data structures. In the order of granularity, Hive data is organized as follows. Databases first. These are the namespaces that separate the tables and other data units from naming conflicts. Tables, that's the collection of files stored in the same folder location. The schema, again, can be applied on read at any time. It's very common to see a folder that's called customers that's in a folder called customer.db, and then hundreds and hundreds of files are in that customers folder location and can be queried with Hive. And again with the schema on read. An example of a table could be the page views table, where each row could comprise of the following columns, which is the schema, a timestamp, a user ID, a page URL, a referrer URL, and an IP address from where the page request was made. This is an example of a table and the schema that comes with the table, all managed by Hive. Some Hive data structures that are commonly used are partitions. Each table can have one or more partition keys, which determines how the data is stored. Sharding is a common term used in other databases. Partitions, apart from being storage units, also allow efficient queries to easily identify rows that satisfy the selection criteria. For example, a date partition of type string and a country partition of type string partition columns that make it easy to search the date and the country within the date. A very common technique. Another example could be you could see partitions created for years. Let's say 2000 to 2018. Each of those can be a folder and makes it searching for a particular year very easy. Buckets or clusters, data in each partition also could be divided into buckets based on a value of a hash function of some column in the table. In the page views example, the table may be bucketed by user ID, which is one of the columns, other than the partition columns of the page view. This can be used to efficiently sample data even further. How do you use Hive? Well, Beeline is the preferred client tool. There is a command line interface, but that's being deprecated. It's still out there. You could still use it for testing and seeing that your Hive environment is operational, but most organizations use Beeline, as in this example right here, Beeline with a connection string, and in this case using Kerberos, the Hive principle. Once you're connected, you can create tables and data managed on disk that resides in the hive.warehouse directory. A common place for this would be apps/hive/warehouse, and then all of the databases and tables will follow under that directory. Here's an example of a create table page view, and you can see it's stored as a sequential file, and it's partitioned by date and country. You could insert data into a table by querying other tables. This is a common SQL technique. You could see here, you could select page views, star from page views, where the date equaled such. you could load data into tables from the local file system, and this is very common in the Hadoop world. The data is coming from the outside. It's not in the Hadoop cluster, and a lot of times data is staged on edge nodes and copied from the local file system into Hadoop. And you could see here the load data from local, load data in path into the table page view. You could create external tables also. This is where the data is managed externally. The difference here in the create external table is the location is not in the default Hive directory that's configured in Hadoop. It's in this directory here. You could see user, data, staging, page view. And then you would put the data in from local using an HDFS put command, just like you're putting in data for HDFS to run with MapReduce or any other type of Hadoop file system tool. With the location being external, now if you delete the database or you delete the tables, you can leave the data intact. And this might be common for wanting to have a view of the data outside or a use for the data outside of the Hive data warehouse. You can perform analysis of the data by querying, and this could create a MapReduce job. You could see the select users.gender count and group by. This is common SQL that most users and analytics professionals in organizations are very comfortable with using. The Live Hive proxy, this is WANdisco Fusion's ability to proxy Hive requests and replicate them across clusters. A lightweight thrift server that provides a Metastore interface to the clients. The clients connect to the proxy via the relevant hive.metastore.urs property parameter that is in the advanced Hive configs, and that's where WANdisco Fusion, upon installation, configures that URS to point to the proxy. Pattern matching rules and the replicated location are used to define the scope of replication, and we'll cover that in a little bit more detail later. But WANdisco Fusion allows you to say, for example, I want to only replicate tables that start with the name customers, and I want to replicate tables that start with the name suppliers, or databases, for example, that will start with something like sales. That replicated location and the scope matching rules are all defined in the Live Hive proxy. These are then passed to the Fusion server, which has its own thrift server to receive the messages from the proxy. The Fusion servers at each zone execute the transaction to their local Hive Metastore service. And here's an example of the proxy architecture. The topology diagram shows the standard Hive topology and how it looks once the Live Hive plugin is installed. The proxy intercepts traffic from the Hive clients and passes them to the Fusion server to replicate, in which in turn directs traffic back to the Hive Metastore for local operations. You can see here the Hive clients will make a call, a beeline call or a Hive command line call, and the Live Hive proxy will intercept it, and then Fusion will coordinate with remote zones, and then the proxy can interface with the Hive Metastore service and the Hive Metastore database on the local zone. Live Hive uses the installed Hive libraries, a runtime dependency, and Metastore configs for easy packaging and compatibility. The Fusion server has a Hive plugin loaded that can receive thrift requests from the proxy. It can also read and write to the Metastores for a consistency check and repair operation. The Live Hive Server 2 template. What is it and why do we have it? On Hortonworks, The Hive Server 2 service defaults to using an internal embedded metastore. The Hive Server 2 template modifies this Hive Server 2 template to use that Hive metastore URS that is configured by WANdisco Fusion. So this is where that comes into play with Hive Server 2. This allows Fusion to intercept thrift requests for the Fusion server to replicate. And then in turn, it redirects the traffic back to the Hive metastore for local operations. That is present in Hortonworks. Installation. It installs on pre-existing Fusion ecosystems. For example, if you were going to install Live Hive and you had a cluster of a name node, 5 data nodes, and an edge node, you would take an edge node and install Fusion, and then you would install the Live Hive on the Fusion edge node. You download and run the CLI Bootstrap, just as other Fusion installs, but once you're done with that piece, you're directed to the Fusion user interface, and you click Install from the Plugins panel. The stacks are then downloaded, or the parcels if it's Cloudera, and you need to restart the manager. You can click through, and it provides the details of the Live Hive proxy and the environment it's connecting to. Kerberos can be configured here if it's installed. The installer then deploys and configures the 2 stacks, amends the Hive service configs, that's again the Hive metastore URI, and installs the Fusion Server Hive plugin, and then restarts are needed to enable. Once it's done on all zones, you need to go to one zone in the UI, the settings page, and find the Live Hive plugin panel at the bottom and click Activate. This deploys the distributed state machine to provide a platform for Hive metadata coordination. And here's an example of what the configuration looks like in the installer. The Hive proxy security, you can see you can manually set up Kerberos and validate that your Hive principal is found and is correct, and also the KDC credentials. If Ambari is managing your KDC, you could validate there, all provided in the install. And then after that, you just click the next steps and you can continue on and finish the installation. Configuration and file layout. You could see that the Live Hive Fusion Core plugin, NoArc, creates the following in the RPM. And the proxy creates the following. These are used here for just reference. The ETC WANdisco Fusion plugins Hive, Live Hive, Site XML. These were where the key changes are being made and stored. You could see the replication path. You could see the host, the principal if Kerberos is being used, and most important, the thrift and port and the remote thrift and port URIs. All of these are stored here, and this is an important file to view and look at if you run into problems. Separating layers of coordination. Because Fusion has to coordinate the metastore and make directories for the tables in HDFS, layers of coordination are needed. This is in the etc hive conf hive environment sh, and you could see that if statement there that says if the service is metastore, then export Fusion replicated disabled true. Does that so simply the global sequence number 1 to create the table. The Hive metastore service creates the table in the database, and then the corresponding directory is created with the global sequence number 2. That's the idea of separating the layers of coordination. Configuring replication. Pattern matching is done on the databases and table. If a table matches a rule And the location is a replicated folder, so there are two pieces to it. There's the Hive configuration for the matching, and there's still the HDFS or HCFS compatible directory that needs to be replicated. Then the metadata update gets coordinated. Here's an example of what the screen looks like. The Hive configuration is here, and you can see the database will replicate any database that starts with Alex. So Alex 1, Alex 2, Alex 3, those databases will be replicated. And tables, all of them. The star will say all tables in Alex's databases. But the key is the HCFS data, the default for Hive, Apps Hive Warehouse, must be replicated also. The replication rule must exist, and this would be an example using an internal Hive managed database. Hive rule consistency check and repair. It's used for seeding metadata to empty or new clusters. Each rule can be checked as a whole, and individual databases or tables can be repaired. It's separate from HDFS replication, honoring the Hive architecture principle of schema on read. And that was displayed in the last slide where you see there's the replication rule for the HDFS data and the replication pattern matching for the Hive databases and tables. Here's an example of the status tab in the user interface for the Hive rule. And with this, you can do the consistency check status, and you could do the repairs. One last plugin to cover, the Live Ranger Proxy architecture. This is a relatively new offering from WANdisco, and this allows customers and users of Fusion to replicate Ranger database policies. The Ranger is another layer of security that's provided inside a Hadoop cluster, and the policies are stored in a SQL database, very similar to the way Hive stores its metadata in its Metastore database. And the Live Proxy works pretty similar to what we have for Live Hive replication. You can see the Live Proxy intercepts the call, and Fusion does the coordination, and then the policy databases are replicated. At this point, it's all policies. So for example, if you had a user named Bill, and you said, I'm going to set up a policy that Bill can read, write, and access this directory in Hadoop. Let's say it's just the user's Bill sales data, and you save that policy with Live Ranger in that cluster, that will get replicated. But you have to remember, it's going to replicate everything at this point. It's not going to be selective replication. This concludes the WANdisco Fusion lesson on Hive, Live Hive, and other plugins.